In this video, we're looking at absolute value inequalities in one variable. And we're going to begin by going back to Algebra 1 and reviewing what it means to have a linear inequality. So if my inequality is 1/2 x plus 4 is less than or equal to 2. My goal here is to get the x by itself, so I'm going to subtract 4 from both sides. And now I've got a 1/2 x less than or equal to -2. To get that x by itself, I'm going to multiply both sides by the reciprocal of the coefficient. So 2 times 1/2 will cancel, leaving x by itself. I have to do the same operation to the other side. So x is less than or equal to -4. To sketch the solution to this linear inequality, I'm going to have a closed circle at -4 on the number line because of the equals that is with my inequality. That tells me that the -4 endpoint is included in that solution set. It's inclusive. And I want to keep the x's that are less than or equal to that -4. So I shade down the number line towards -infinity. And this number line would represent the solution to that inequality. In the next inequality, I'm going to subtract 1 from both sides, and that leaves me with a -3 times x is strictly greater than 1. And when I divide both sides by the coefficient on the x, I'm dividing by a negative number. And if you recall from Algebra 1, whenever you divide by a negative or multiply by a negative, you change the direction of that inequality. So the greater than symbol becomes a less than symbol, and x is strictly less than -1/3. Sketching the solution to this linear inequality at -1/3, we're going to use an open circle to show there is no equals, so the -1/3 is not included. And again, because it's a less than, we shade down the number line toward -infinity. So the thing we want to remember is that if you multiply or divide each side of an inequality by a negative, you must flip the direction of that inequality symbol. So greater thans become less thans become greater thans. Another thing to remember is we used closed circles when the endpoint is inclusive, when there's an equals with your inequality, and we use an open circle on the graph to indicate non-inclusive endpoints. So let's go ahead and start with example 1, looking at absolute value inequalities. So the absolute value of x is less than or equal to 5. Remember, we would break our equations into two cases, right? The first, where we take the expression in absolute value and we make it equal to the positive of the other side. So x is less than or equal to 5. The second case, however, is the x, and we have our symbol, and we would negate the other side. So the x would be related to -5. But because we're using a negative on that opposite side, we change the direction of that inequality from a greater than equal to a less than equal. So what this means is that on our number line, we have -5 and we have a +5. The x's are going to be less than or equal to the +5. There's an equals, so we use a closed endpoint, and we're shading down the number line towards -infinity. But the x's are also going to need to be greater than equal to -5. So we have a closed circle at -5, and we're shading up because we want the x's greater. And that shading then gets locked between because both of these have to be true. The absolute value of x less than or equal to 5 means that x is greater than or equal to -5 and that x is less than or equal to +5. That's the same thing as saying -5 is less than or equal to x, which is less than or equal to 5. All of these statements are equivalent. Now, for the or inequality, or occurs when we have a greater than symbol with our absolute value inequality. When we take this expression inside the absolute value and we set it into its two cases, x is greater than 5, or the x is related to the -5 by switching the direction of that inequality. So x is less than -5. On our number line, we would have open circles at -5 and at +5 to show that those endpoints are non-inclusive. There is no equal sign there. And x is greater than 5 shades up toward positive infinity. X is less than -5, that shades down towards negative infinity. And so we see there is this giant gap in between. Instead of overlapping the way the and inequality did, the or inequality shades apart.